So today is the first in our series for version 7320 for 3DCS. Like I mentioned on the blog and in the invitation, all of the new updates are available for our CATIA integrated version and our multicad version and our CATIA V6 3D Experience integrated version. So regardless of whether you're working in CATIA V5 or working in our standalone, you'll have access to these new updates and features. All right. Looks like we're having a little bit of trouble with the phone line. I just want to make sure everyone can hear us and get on all right before we get underway. Can I see raise of hands if you can hear me okay? Do you see a couple? Okay, good. All right. Just want to make sure. Okay, that handled that. All right, fantastic. Thank you very much. Okay, so let's get going. I don't want to take everyone's morning. I know we all have things to get to. So today's webinar is going to be about 45 minutes. We'll have a couple minutes at the end for some Q&A. So today we'll be talking about Locator Sensitivity Analyzer, or LSA, because it wants to say that 5 times fast, and Alias Display, both new features for our 7320 release of 3DCS. Like I mentioned, throughout the entire webinar, please post your questions. Don't wait till the Q&A session, as you might forget it, or it might pertain to what we're talking about presently. And if your question is an expansion of what we're discussing, sometimes it helps to send it in so we can answer it right away rather than waiting to the Q&A. So please ask your questions as they come up. Don't worry about holding them off to the end. If we do not get to them because it's got a longer answer or you want a little bit more feedback or a specific example, we can also do a follow-up afterwards. We can do an email and set up a follow-up meeting. Having a little bit of trouble with the phone line still. All right. Once I get Gary going, I'm going to investigate and see if I can't figure out what's going on there with the phone line. Why that might be having issues. I appreciate your patience. Sorry about that. Like I said, we have power out at the office, so unfortunately, last minute we've had to change our location for the presentation. I do want to note, though, that we have a couple upcoming webinars. Today is the first in our series. We're going to be going over a number of other new features, as well as some updates to existing add-ons and features in 3DCS. We'd also like to point out some of the add-ons that might not be used by a lot of our customers or that you might be interested in taking a look at. So coming up in August, we're doing color mapping and process capability database. We've got compliant modeler and FEA. In September, we'd like to show you how to bring in real data from measurement devices into your 3DCS model and apply it. Okay, so if you're having any trouble dialing in, I know which you might not be able to hear me otherwise. I'll put it in the chat. The alternate dial-in number is working, so please use that if you're having any trouble with the phone lines. Once again, I apologize for that. Unfortunately, that is outside my hands. I will give GoToMeeting a call after this to see if I can't talk to their tech support about the issue. So sorry about that. Continuing on, like I said, in September, we're going to be showing you how to bring real measurement data into your model so you can simulate using actual data, so you can see those mean shifts and see how your actual data plays out within your model and simulation. We're talking about Mechanical Modeler And we've got some nice special cases to show you with some neat models to illustrate that. We'll have a quick tools webinar, which will show you how to use a couple add-ons and some features within 3DCS itself, including the new Alias display to help speed up your modeling time. As I know a lot of times when you're making a 3DCS model, especially on a larger assembly, it can take quite a while. So we want to show you a couple tips and best practices that our modelers use that might help you speed that up. And then we're looking to have a reporting and presentation webinar, which will show you some ideas on how to create different reports out of 3DCS and how to convert those rather quickly. We also like to highlight some of the new reporting features that we're working on right now to give you better and more robust reports out of 3DCS. If you want to check in and see what we have going on, we post all of our events, and I post all of our invitations to these events on our blog. In addition, after this webinar today, there's a 2-question survey. It's just 2 quick questions. First question will be, do you want me to sign you up for the entire webinar series? So I can automatically sign up anyone who's interested in the entire series. So you'll just get the reminders that it's coming up. You don't have to worry about signing it up yourself. Or if you want us to reach out to you, answer any questions, or show you anything in a little bit more detail, that's what the other question's asking, just to see if you'd like a follow-up. So it's just a 2-question survey, real fast at the end, once the webinar is over. Now, it looks like almost everyone on the call is a current DCS customer or client or partner. So everyone knows that we're quality assurance for manufacturing. We identify and reduce variation, and we do have clients and customers in aerospace, automotive, electronics, consumer goods, heavy machinery, medical device, and actually some oil and energy companies. So we've been working with a lot of different industries, a lot of different applications. We, of course, do software and services. So if you need a service job done or you need some help with some modeling, we want to make sure that you know that we're available. Now, I know on the an initial login, it might have shown Brenda's picture. Originally, Brenda Quinlan, one of our senior variation analysts, was going to be doing the presentation today. However, I was able to rope Gary Bell into doing it. Brenda is unfortunately indisposed at this moment, working on a different presentation. So Gary's going to be helping us out. Gary is one of our senior variation analysts. If you've had a demo or gone to some of our other training sessions, you've probably met Gary before. He does a lot of that work for us and is one of our most experienced modelers here at DCS. So we're very lucky to have him with us today. Gary, are you still you're still on the line, right?
I'm still here. Can you hear me?
Good. All right, Gary, at this time, I'm going to be passing the presentation over to you.
Okay.
All right. Yeah, once again, I'm sorry that I haven't changed it over to Gary on that screen. All right, Gary, say hello.
How you doing, everybody? I think I should update my photo. You can see that was a very nice photo on a nice summer day at a football game. Maybe I should make that picture a little more professional. But Ben, I guess I'm going to ask you, can you see my screen?
I can see your screen. Your audio is just a little choppy, so make sure your screen's set up nice in front of you so that you're facing the microphone.
Okay, I'll do the best I can.
No problem.
So some of you, I'm going to get started. I saw in Ben's presentation that coming up is color map. We're going to get a little bit of a brief visual of color mapping today, only because I need to use it to help you get a better visual of what LSA is actually doing. So first off with this model, just so that you got the background of it, I'll go ahead and assemble it. And you can see, it's a suspension system. I hid the tire, so all we're doing is looking at this knuckle assembly. When I deviate it, you can see it bouncing around due to part tolerances and your assembly method. I'm going to go ahead and turn color mapping on. And when I deviate it, now you can see it's actually changing colors based on where this part is from its nominal position. And you can notice that something is always red because our color mapping is checking the parts against their nominal design position, and the part that's the farthest from its design will be red, and this deviation here on the right-hand side you can see is changing for every build. If I go in to my color mapping and I lock my scale to 5 millimeters of variation and then deviate, now you can see it's not red. There isn't any red unless a build actually produces something that's outside of 5 millimeters of variation. So locator sensitivity analysis, that is this button here. I'm going to pull this toolbar out. We put it down here in Advanced Analyzer Optimizer because it is an analysis tool. It essentially analyzes the sensitivity of your locating features. So what I want to do right now is I want to focus on just this knuckle. I'm going to go ahead and I'm going to deactivate all the moves except these down here. And you can see I'm simulating a tool over here. So what I want to do is I want to understand the multiple different geometric effects based on changing my locators. So if you look at this knuckle, it attaches here, here, and here. Well, I want to understand, does my variation get better or worse if I, made the location tighter? And that's what these moves are. So if I click over, you can see it's highlighting, and I drew some lines over here so that you could see the actual geometric area. So this is my original location method. This is location method number 2, location method number 3, and location method number 4. Now, those of you that are familiar with AAO, Advanced Analyzer Optimizer, you do not have to hit the auto generate. You just have to do a nominal build, and so now you can see all these different options are active, and it attached it to my tool over here. Now I'm going to hit locator sensitivity analysis, and you will get this dialog box. What this is going to do is it's going to move all the target positions of the target points in each of the moves. It's going to move each point independently plus or minus a ½ millimeter, and then it's going to look at the entire geometry of the part for its maximum amount of variation, both X, Y, and Z. So the first thing I'm going to do is just say calculate locator sensitivity. Now this takes a little bit of time because it's got to take each move point and move it to its plus and minus 0.5 position, and then look at all the mesh nodes on the feature to see what is the maximum amount of variation. And then it's going to do that for all 4 of these move types. So what this is allowing us to do is it's allowing us to analyze in advance, what if we modify our locators? What if we spread them out? What if we move a locator higher or lower? And I'm doing it specifically on an individual part, but we can do it on the entire system of the model. So if I turned on all these moves, I could analyze it, and it would tell us which move was most critical to my overall assembly. And as I'm trying to fill the time while this is calculating, so you can see this is the calculation time for just a knuckle. And this knuckle, has got some data to it, so the mesh on it could be quite dense. And, the more parts you have and the denser the mesh you have, the longer this is going to take. Once it's done, you will get some numbers here that's going to tell you the maximum overall variation caused by move number 1. And it's showing it in all X, Y, Z locations. So I can customize this. I don't know if it will let me do it while it's calculating. Oh, looks like I can. So here you can see, I can say, well, just show me the X variation or the Y variation or the Z variation. Generally, I just keep it on showing all the X, Y, Z's. And what it's going to do is it's going to root sum squared the X, Y, and Z for every mesh node and give you that overall variation.
Hey, Gary?
Yeah.
Can you say that again? You said it's going to give you the root sum square for...
Yeah, so if when we say show all X, Y, Z, you're only going to have one number in here. But what that number will be, it'll be the X variation squared plus the Y variation squared plus the Z variation squared, square root. Because that's how we give you a single number for the overall variation. So we have 40 minutes. I hope I don't use up all 40 minutes just calculating this. There we go. So it's complete, and now you can see that it shows you that the maximum variation caused by move 1 is 2 millimeters, move 2 is 2.4, move 3 is 1.48. If I click on these, it actually will color map this, so you can click through your moves, okay, and the color map is all looking the same, and that's because I fixed my color map toolbar here. So since I can see that the maximum variation here is 2.5, I'm going to come over here to my color map toolbar, change this to 2.5. Okay, so now you can see it will show, okay, this move, you know, has worse effect on the knuckle than this one. You know, and it gets better and better. So with this, with the locator sensitivity analysis, I can look at multiple different locating strategies for the same part and see which one is, you know, least sensitive or, you know, controls the part the best. And obviously the bigger the spread, the, you know, more controlled the part will be. We know that from a GD&T and dimensional management. But, you know, some stuff that's really interesting is I actually made up these options, and you can see this locator move number 4, I would have thought was going to be my best option because I thought it was a bigger spread. But it's actually not as good as move number 3. So one of the things that this is telling me is that the original design of a knuckle, you know, where the ball joints are hovering straight above the axis, you know, that's a better design. This is the exact same location system as the original one, except a bigger spread. If I go down farther and up higher and farther out, I get the best results. So then you can see, if I want, I could change this, and I could say, well, just show me the X variation. Okay, and you can see the X variation is less. Or I could say, just show me the Y variation. So you can break this down by variation, and this is looking at the overall part, or you can look at each individual locator. Okay, if you turn it on and you want to look at each individual locator, now you can see that it's showing you that this is the move, and this is locator number 1, locator number 2, locator number 3. And you can see the overall variation effect of each locator. So not only does it tell you, you know, which move is more sensitive or less sensitive, or, you know, produces less variation, you can analyze which locator in that move is more sensitive, so then you can start seeing if there's ways you can adjust that. So, and because I only have one part in my move list, then it's only listing one part here, but I have 4 different moves for that particular part. That's what I got. Ben, should I move on? Should I move on to alias display or open it up for questions here?
Let's move on to alias display.
Okay. So locator sensitivity analysis is
Here, hold on a second. Before we move on, yeah, let's give a minute or two right now for some questions. I have 1 or 2 coming in. Can you compare different types of moves?
Absolutely. I just, to keep things simple, I use the 3-point move, but it can be any, yeah, you can mix or match any type of move.
So you can really use this as a way to maybe do different move scenarios and then check to see which ones are going to give you the best effect.
Absolutely.
So this would be a good way to test different assembly, not just the sequence, but the way you're assembling it.
Absolutely.
Okay. All right. Let's see. If I'm using mechanical modeler or compliant modeler, and I've got compliant moves or mechanical kinematic moves, would this allow me to test those?
Very good question. It does not work.
Have we tested that? Oh, like us as modelers, or?
Yeah. So I would say I would stay away from a mechanical modeler, and the reason it's hard for us to calculate it for mechanical modeler is there's multiple solutions for a move. So when we deviate a target point, you know, plus 0.5 or minus 0.5, what mechanical modeler does to assemble that could be different every time. So we, you know, we don't recommend using this for mechanical modeler moves. Compliant modeling moves, which are, you know, sequential, it should work exactly the same.
Yeah, compliant modeler just adds another tolerance type, pretty much, into the calculation.
Compliant modeler is taking a step plane move and making it, instead of a 3-2-1, it can be a 15-3-2. You know, it's just it's fixing the part completely when it's done. So it would work. It will work with the locator sensitivity analysis.
Okay. All right. Do we have any more questions? I know locator sensitivity analyzer. It's fairly straightforward as another way to analyze your current setup model and check your moves. We want to try to give modelers other ways they can determine, you know, best case from a series of different options. Okay, fantastic. So here's a really good question. With mechanical modeler, could this give us an idea of how things are moving within the assembly, just to understand overall how the system behaves?
I'm not sure if I understand the question. Does that have to do with locator sensitivity analysis or mechanical modeler?
I think in locator sensitivity, could it give us a rough understanding of how the moves are affecting the model?
That's correct. That's correct. But the way it does it is it takes one target point at a time and deviates it plus or minus 0.5. So the difference, you know, so to give you an example, with a rigid body move, if I'm moving the knuckle to the lower control arm, and I take this lower control arm and I move it backwards 0.5, and then I attach the knuckle, I can calculate the variation. With mechanical, if I move the knuckle backwards 0.5, mechanical might, to solve this, might say, oh, well, I want to rotate the lower control arm down a little bit and then attach it to get the upper control arm to attach. So I have not analyzed a mechanical modeler with LSA to see if it makes any sense or not.
Yeah, it's still really new. So So I think some of our modelers haven't. I mean, we've done tests in development and post development, but I don't think it's been out long enough to have been pushed through all the different possible scenarios. So that's something we should look into, especially in our rest of mechanical modeler webinar coming up. That'd be something good to check out in preparation for. As a follow up to that same question, really quick, would it be possible to understand how locators are driving possible motions within Mechanical Modeler? Does that make sense, Gary?
I'm thinking about it. I mean, if we understand that we're calculating the variation of the part by moving the target, it's like a different form of sensitivity analysis. We can control this number. We defaulted to plus or minus 0.5 so that it was unitized to 1 millimeter. But I guess I still don't see. I suppose you. No, I don't know the answer to that. I'm sorry.
Let's follow up. Let's follow up afterwards and do a test.
That's a good question.
That's a good question. I got two other quick questions. First off, can you do variation in a specific vector direction?
No, it's just X, Y, Z.
Okay, so you can't choose a specific direction at this time. Okay, does it show the effect of the locator at each move, just like geofactor?
Yes. Yeah. It will take each locator and move it plus or minus 0.5, we'll say, and then it will look at the entire part and find out what the maximum X was if I'm displaying X. So it's very much like geofactor when this is set to plus or minus 0.5, because then the multiplier, the geometric effect is times 1. So if you have a geometric effect of 2, 2 times 1 is 2. That's kind of why we have this defaulted to that way. So the answer is yes.
All right, fantastic. So yeah, one or two of those questions we're going to have to do a follow-up afterwards. One problem with doing early webinars after a new release is new features we just haven't used that much outside of a standard context. So it's fantastic. I'm really glad you guys are asking questions about these specific instances. I just have one last note I want to check on for myself as well as some of these new features. I've only had some brief training on. Gary, is this feature LSA? Is this only available in AAO, or does this have anything with the standard 3DCS setup and GeoFactor?
Yeah, no, it's only available in AAO.
So we moved into AAO as one of the advanced analyzers?
Yep.
Okay, so that was one thing that had been talked about. Now I know AAO is one of our basic add-on modules. So if you'd like to try it out, we'd be happy to set you up and let you take a look at it. So I apologize. I think in my blog I mentioned it might have been part of the original 3DCS, but it is part of AAO, one of our add-on modules. I think in Alias Display, while we're on this topic, Alias Display is part of the standard 3DCS setup, correct?
That is correct.
Yeah, I just want to get all of that out there so everyone is clear. Good. All right, so I think that's all of our questions at this time. All right, let's move on to Alias Display.
Okay, so now I'm just going to go back to my regular model. So I'm no longer testing this, and I'm building it as I would build it. Original design. You can see it assemble and deviate. Now you can see, interesting enough, now you can see this is red a lot, and that's because, again, I fixed my color coding scale to 0.5 or 2.5. We'll go ahead and let this go free. So that it looks like this. Now, when you create a model, we all know that that we got to write moves, we got to write tolerances, we got to write measurements. We create points, and we need to give the points names. You can see here I got upper B3, upper B4, because I was creating points, associating them with this part, and I was setting their names. And in this move list, you can see I didn't bother giving this any kind of names here. I just said move 1, move 2, move 3, move 4. Well, this doesn't help later on when we want to try to understand, well, what's this move doing? What's it locating? It requires a lot of studying by the modeler or the guy taking over the model. So we've developed alias display. Alias display is in your preferences, and it's right here. And what this allows you to set up settings so that you can develop standard naming conventions. If you want your name to always have the object part with the word to go to the target part, everything, you can set everything up here. So if I say I want to turn on my alias displays for moves, if I turn this on, you can see it's already set up to say VP, 2VG, and VN. I'm going to hit customize so we can see what that is. And it says, okay, first move part name. The 2, I can type that in myself. I could say 2 from, so I can customize this. These are all the variables that we can steal or use from the model. So if I leave this alone and I just turn it on, and then say apply, you can see how it automatically changed the names. So now it's lower to plunger, plunger to frame, lower to frame. So this stuff came up automatically because it is taking it from the name of the parts, upper, lower, frame, and it's just copying what we put in here. So if I turn it off, it goes back to my original move. So this allows you, if you set this stuff up in advance, then the move automatically will fill in for you. So for instance, I'm going to turn it back on, and I'm going to write a new move. Double click. Trying to keep things as simple as possible, so I'll say 2-point move, add all objects. I'll go ahead and pick this twice. All targets, pick this twice. So it's moving the steering knuckle assembly. If I say OK, it's saying steer to steer. I must have. Okay, so I called this tool steering knuckle LSA, and I'm moving the steering knuckle, and it's picking up only the first 5 characters. That's why it's saying first 4 characters. That's why it's saying steer to steer. Move 22, 2-point move. So if I come back to my preferences, move type, VT, that's a default. So if I added this, it would say 2-point move twice. But these are the types of items, and you can do this for both moves, tolerances, or measures. So let's go down and see if I turn on measurements, customize. Measurement type is the first thing. Measuring it from the part name, M0 to the part name. So, and I already had some names because I'm used to naming stuff by default, but if I turn this on and say OK, now you can see it automatically added point distance, wheel to wheel, wheel to wheel, wheel to wheel, frame to wheel. So what the alias display, the intent of your alias display is when you get ready to do a model, come in here and fill this out, how you want your naming to be displayed. Then when you go into your model, you don't have to worry about it. You just continue on as you would and say, okay, I'm going to write a feature distance measure, and I'm going to, am I putting it in the right location? Yeah, okay. And I'll measure this face to this face. Okay. And so it automatically filled this thing in. It is measurement number 23, but it filled in feature distance measure, steering to frame, and then it's saying feature distance again, and that's only because I must have that in my alias display setting. So if I go into my measurements again, measure type MT, yeah. See, so we if you remember a long time back, we automatically started adding descriptions at the back, measurement type, move type. So now because I turned on MT here, move measurement type, it's adding it again down here. And you can see you can control, you can say you want these settings to go as prefixes or suffixes. This is where I'm controlling the number of characters. So when you see this lower to frame, it's showing 5. I'm going to change this to 3. Now it's ST to FRA. If I come in here and I put more spaces, okay, so hopefully that gives you a feel. So if you sat down with your group and you said, this is how we want our naming convention to be for your moves, your tolerances, and your measures, it's a one-time setup here, and then you go off and you do your model and everything gets named for you. So the intent is commonizing, so everybody's doing everything the same way, and eliminating keystrokes so that you don't have to do so much typing as you're creating the model.
Hey Gary, I got 2 quick questions for you that are pertinent to what you're talking about right now. So let's say on my moves, I want to number my moves also. So I see you've got move 1, move 2, move 3, but what if I want to put something in custom without it being automatic? Like, can I rename an automatic named move? Like write a number in or change the name manually?
Oh, that's a very good question. So like this is saying move 1. If I double click on it, it's move 1 here. So let me change this to move 2, 2, 2, 2. So I can change it there. And now let me go back to my preferences and turn off alias display for moves. And it's just move 2, 2, 2, 2. So if you wanted to change the auto numbering feature, I'm not sure if that is available in the alias display. You'd have to click on moves, customize, and see what do we have. We have the move name, the type of move mode, dominant direction, part name, target name, move type, move direction. Yeah, so I guess if you're asking the question, can I set it up in here so that it labels my moves by 2, move 2, 4, 6, 8, 10, I'm going to say no.
Okay, so right now there's some automatic settings that you can work with. You can customize the basic name within, and you can move depending on where you want to put the variable naming
Correct.
aliases around. So
Correct.
2 follow-ups on that then. I can shorten the measurement information. For example, instead of point distance, could I just have PD?
Right now, I'm going to say
So right
no.
here under measures, it says point distance. Can I have that say PD instead?
You can. This is okay. Shoot.
We'll have to double check.
Well, you can, and Jason said avoid talking about that at the moment. I'm looking. Just give me 1 second. It would have been tips and tactics, alias display.
We have
There's a text document in the config file that we link to, and you can modify that, and then you could change it so when so I'm saying measure type, which is that's in moves. Let's go to my measure type. Yeah, measure type. So right now I can, if I say, if I put MT up here, I can control the parentheses, and so I could take that out, but it's going to say point distance. If I wanted to say PD for point distance, I would have to edit a text file that's in our config file. So I want to say it can be done. We do want to give the user or the administrator or the controller the ability to do that, but as a quick click buttons inside the software, this is what you get at the moment.
So just to make this more complicated, let's so if I'm doing a big part of this is when I do my 3DCS automated report, all these names, the names used in the report, if I set it up with alias display, correct?
Correct.
Yeah, I'm 100% sure of that.
Yes.
So if I did a study, say I did a model in a previous release and I bring it in with 7320, I mean, I can instantly start renaming stuff with alias display, right? Because we did that with this model, right?
That's correct.
Okay, so it's no problem. There's no kind of as long as you have the latest software, the 7320, where alias display is available in.
Correct.
All right. All right, I got a couple more questions. These are actually pretty good. So you have a little bit more to show with alias display, though, don't you?
No, that's it.
Okay, good. All right, that's actually good because we have a couple of questions. This is a good time for this. We're at 45 minutes after the hour, so we're going to go into a Q&A while we're still on alias display. So if you guys have to run, I will be sending the recording out, but I'd like to see if we can address these questions right now. Well, Gary has the software open and is available. So here's a really good one. So if you need a solution for numbering which moves have to be activated or deactivated for different product positions, would there be an easy solution for that? So can I differentiate between 2 different moves? Hold on.
Yeah, that is not. I know exactly the question that's being asked, and we do plan on developing the ability to have move setups so that you can actually activate and deactivate different sequencing. But that's not controlled here. This is purely a naming convention.
Okay, and so here's a really good point. So if I'm working in my model and I just like all my moves, say numbered move 1 through 12, like you have on the left side, all right, and I know I can see I have my descriptor, so I don't need to have these really long names that are going to be getting in my way. But once I'm done with the model, I'm passing it on to the next, the next modeler or to someone else within the team, and I have to have those larger naming conventions there so they can understand what I did. So I could set up, just confirm if this is correct. I can set up alias display, right, and then toggle it on and check, and then I can turn it off, and it'll keep those settings. Yeah, so just like what you did.
Yeah, absolutely. So with Alias, interesting thing enough, if we did this model in this version and we have Alias display, and for those of you that understand how we can pass data up and down versions with WTX, I have a feeling if we saved this model and we opened it in an older version that did not have Alias display, it's going to come in looking like that. So to answer your question, yes, you can just do your moves, let it label it move 1, 2, 3, 4, 5, 6, 7, and later on you can set up your alias display, and when you turn on your alias display, it will change it automatically, and you can make them all long.
All right, we got a couple other really good questions here. So when I'm doing my sensitivity analysis,
Yep.
when I'm doing my sensitivity analysis, it uses the alias display names, correct?
Correct.
Yeah, those are my new names for my points and moves and.
That's the whole purpose. Is it's supposed to make it more easier to understand in your reporting, your sensitivity analysis. That's correct.
That's fantastic. Good. Yeah. Also, what's nice is when I save my model, I can save all of my alias display conventions and stuff within the model itself, right?
Correct.
So you could have someone early in the process set it all up and then pass the model on to team members, right? And they'll have access to the alias display and they can quickly use the proper conventions that the team wants to use.
Correct.
So if I've got different levels of the tree, so say I've got I got moves here, I see they're all together. But if I have got different parts in my part tree and I got moves associated with my different parts, yeah. So I've got them. If I have some moves up, with my lower arm or my upper arm, can I set those different tree sections with different naming conventions, or is it only global?
Man, I tell you.
Hey.
You give them a little bit, and then they want more.
We have a lot of our best customers and clients here with us today. They're asking the real deal.
Yeah. So the answer is no. It's global. It's global because it's in your It's in your preferences, but of course that's exactly what somebody would want. Set up different preferences for different levels of your tree. But the answer is no.
Not at this time. Okay, that's something. Can we make a note of that? I think that's something.
You just did. The whole thing is recorded.
Oh, that's true. That's true. I know, but let's make sure we let the development team know about that. That'd be a really good patch update.
Okay.
I got one more question. I want to make sure I understand it. The Excel report generator. Oh, yeah. So there are some of the alias names use symbols, such as the stars. Have we done a Excel report to see if any of the symbols we're using in the names for alias display have issues coming out in the Excel report? I don't think they would.
I don't know if we've tested that. I could test it right now, but I guess the answer for me is I'm not 100% sure. I would throw some symbols in here and export it to an Excel and see, but I don't know the answer right now.
All right, cool. Yeah, so we will we'll double check that.
Noted, and then we'll respond to that when someone knows the actual answer.
Yeah.
Good question.
Mm-hmm. All right, good. So that's something else we'll add on in our follow-up. Make sure I didn't miss anybody here. So if I've got, how does this work with point names? You're showing the moves. Can we
Oh.
rename some points?
Sure. I don't think I've done anything with points, but let's do it.
I think Jason did when he was demoing it for us.
Oh, he did?
I think so. Yeah, well, that was,
So let's see. So I can see that at least in this model, the point names were never addressed. But you same concept. You can add a parent name that the point is in. If it, what type, if it's a DCS point or a feature point, which you don't really need because it shows you it there. Dominant direction. Let's turn on dominant direction. And, well, hold on. Delete. Now you can see this. So let's turn on parent name. I want my point name to list the parent that it's in. It's only going to use 3 characters. So I better come back here and we'll say 5 characters. Go back to my point name customization. Parent name, I'm going to put a couple spaces and feature, dominant direction, a couple spaces. So let's see what that does. So now it should, when I say apply, it should put plung, P-L-U-N-G, with some spaces, then the number 1, then some spaces, and then the dominant direction, then the dominant direction, and then the feature name. So let's see what it does. Yeah, so now it's plunger. The dominant direction on this point is Z, and then the point name, 1, 2, 3. So when you create your model originally, it automatically just says 1, 2, 3. That was my original. So now I want to turn this off. Oh, see, I already had them labeled 1, 2, 3, 5. Must have deleted a point somewhere in the process. But yeah, so now it's just adding the parent name that the point is in and the dominant direction, and it still keeps the point name. And so again, you'd have to kind of go through here and see what is it that you want. You can see that you can customize it with whatever you type in plus these variables. So these are the variables you get, and then you can type anything else in there and it shows up.
All right. Now in our report in Excel, we have a point table. If I rename these points using this, I mean, that's the same thing with the measurements. The new name is going to be in my point table and in my report as the standard name for that point.
Yes. You want me to export this to Excel?
Yeah,
and take
if you could.
Yeah, you could? Sure.
Oh, wait, let's, hold on a sec. Yeah, so do that.
We're looking for plunger 1.
Plunger 1 at the top. Yep. So that exports. That didn't take too long. How long do you think our report would take?
Well, hold on.
Oh, sorry, I'm getting excited.
You are getting excited. Part, point. I'm in my points list, right? Yeah. I guess I was looking for this name.
That's the part you're looking at, not the point.
That's
the point is in the 4th column, D.
Oh, thank you.
Don't thank me. That's one of our attendees is helping out.
Yeah, that's good. Is Jason over there or something?
No. Like I said, we have a lot of our power users on with us today.
Well, Well, I guess I exported and I was expecting to see this. I'm not seeing it.
All right,
So
we'll have to double check that.
I would take that as a note.
All right, we'll have to find out if that's something that.
Art plunger one.
Oh, okay. So one of our attendees has helped with this. So the alias name isn't going to appear in Excel because it's an alias, not the actual name of the feature or move tolerance or measure.
Okay, well,
So-
good. Thank you.
Okay. All right. Do you think it would take? Let's see here. Well, we know it's going to show up in the Excel report, though, right? In the sensitivity.
Oh, yeah, I know. So let's see what happens here.
All right. Well, don't lock your system down.
No. We'll turn this stuff on mainly so that we can see the move list, right?
Yeah.
So we just changed the move list, and I believe I already have this. I'm turning color mapping off. Oops, wrong button, sorry. Let's turn color mapping off. Let's do a nominal build. I'm pretty sure I already ran this, so that will be good. Let's bring the analysis back up.
Oh, that's good.
Okay, so
Oh,
because
look at
this was a mechanical model, and it doesn't run super fast. But okay, so now let's go to the auto report. Now this is still this is still our original old auto report.
I wouldn't call it old.
Well, based on where we want to go with it.
Yeah, that's true.
Let's turn the moves on.
Want to do the Excel one?
Well, I want to do the HTML first.
All right, we'll do that.
I'm guessing if it's in the HTML, it's...
All right, just run it.
I thought I did.
No, you hit close.
Oh, damn it.
You're killing me here, Gary.
I hit close, sorry. I thought, okay, so I got the moves on, yeah. So let's generate the report.
All right, so let's grab a couple of snapshots.
Yeah, this
model's not that big.
Right.
So
let's go to moves. Yeah, so our display is in there. Lower to space, plunger. There's my frame to upper to frame. If I come back over here, yeah, upper to frame. So it's picking up the alias displays. Let's go to the measurements. Wheel to surface Z4Z. Yeah, so it's picking up the alias displays. You want to see it in Excel?
no, it's going to be the same thing in Excel if it shows up in the HTML. Our Excel and our HTML use the same code output. They just
That's what I thought, but hey, you know what? I'll do it. It's quick. I mean, it just lays it out different, right?
Yeah. Unless you froze it.
Excel is a lot slower, that's for sure.
No, it's not. You probably did something. Did it open up in Excel? You have Excel. Oh, no, there it is at the bottom. It's creating it, not the bottom.
No, this is the wrong one.
No, that's right. No, go back. I was looking at the bottom of the, yeah. See, there it goes.
Now, yeah, there it goes.
Yeah.
So it was still creating, that's what I said.
Yeah, I know. I was just in disbelief.
Right. Okay, so here's the Excel. I can see the alias display names here.
Good. Yeah, that's not bad.
No, not bad.
All right. Fantastic. All right. Well, we're actually 1 minute past the hour at 12:01 here Eastern Standard Time in Michigan. So I really appreciate everybody sticking around so long. Thank you for bearing with us today with our technical issues um, at the office. Like I said, I'll be sending the recording out tomorrow. If you don't mind just answering the 2 quick questions after the event closes. After the event closes, I want to make sure that if you want to just have me sign you up for all of these events, I can do that for you and make it automatic, so you don't have to keep re-signing up for the whole series if you want the whole series. Especially if you can't make one of the events, remember I send a recording out for everybody who signs up for it. So if you want me to sign you up, make sure you at least get the recording for all the events. Just go ahead and let me know in that survey afterwards. And I really appreciate everyone bringing your A game today. We had incredible input from all of you, especially since I recognize most of you are our power users. So you know a great deal more about this software than I do. So I appreciate that a lot. And thank you, Gary, for coming and presenting for us. At this time, I'm going to be closing down the webinar so I can get started on the recording. And I hope everyone has a great day. Here we go.
All right. Thanks a lot, guys.
Time to mute us.